You make me feel weird. Feel weird now. Hey, I'm Tabitha and welcome to my space on the internet. In this video, I'm going to be going into creating CRUD operations for a Swift API. CRUD stands for creating, retrieving, updating, deleting, and they're operations that we use to interact with our database. So you have your model, you can create it, you can retrieve it, you can update it, you can delete it. I'll be using the Vapor 3 framework to create the endpoints which will allow our client to perform these operations. Take a second, like, follow, subscribe, share, comment, all that fun juicy stuff so that you can stay connected with me. Okay, the video.
Okay, so if you head over to Safari, Chrome, whatever internet browser you use, to my GitHub, you'll find a Cheese API Swift repository, and this is going to be our starting point for this video. This is currently a repository I'm working on to create a template for Vapor Swift projects. So you just go ahead, download that, SSH, whatever you want to do, get it onto your local computer. Cool, so if you head over into Terminal and navigate to your Cheese API Swift folder, you're going to go ahead and do a Vapor build. This is going to build the project, and once we do that, we want to generate an Xcode project, Vapor Xcode -y, and the -y flag lets this whole scheme know, hey, run it. Now that we're in Xcode, you want to go ahead, head over to Sources, Apps, and then the Models folder, and you're going to make some modifications to our Cheese model. So it's a standard model, has an ID, created, updated at properties, and a name property as well. We're going to do a few updates. So the first update is going to be updating our ID to a UUID string. If you head over to constants, you can see that I do a type alias of UUID string to string. So the ID is essentially a string. And since we did do that modification, you want to remove the MySQL UUID model protocol conformance. And we're going to actually extend our Cheese model so that it conforms to just the standard model protocol. So with the standard model protocol, we can actually define our own custom types for our model. And so we do need to specify the types that we're using for our database as well as for our ID. So the ID is a UUID string. So we're going to do the type alias of ID within this model protocol conformance to UUID string. Now we're also going to add a class property of ID key, which is going to be linked to the ID of the Cheese model. And since we're using the static keyword, that'll be available for the entire class. So once again, we have our Cheese ID, and since it's a custom ID, we do need to have its type specified by conforming to the model protocol. Heading over to the initializer, we can go ahead and initialize our ID as well as the created at and updated at properties. And so the ID is a UUID string, so we initialize that. And then for the created and updated at, we're going to set it to whatever that current device's date is. So with our Cheese model pretty much set for right now, we can go ahead and switch over to our actual Cheese controller. So if you head over to the project navigator, underneath controllers, we have our Cheese controller. So the endpoints. So for our Cheese API, we're going to have an endpoint that returns all the cheeses in the database, an endpoint that returns a single cheese, that'll be a get to a cheese / cheese ID. We're going to create a new cheese by using a post, and then we're going to put to update a single cheese, and then also deleting a single cheese. So much cheese. Now that we know what endpoints we're actually going to create, we can head over to our Cheese controller and start creating them. So we're going to import the Fluent library as well as importing Vapor. Fluent is Vapor's ORM, object relational mapping tool, and it allows us to abstract out our interactions with the database. So we're going to create our Cheese controller struct and conform it to the root collection class. And this does have one method that you do need to implement, which is the boot function. Within the boot function is where we define our roots, and then within the overall struct is where we implement the methods that are called for those roots. So we're going to go ahead and initialize our first path. And so we're going to actually retrieve all of our cheeses. And so we're going to do router.get and then pass in the path. So our path would just be cheeses. And then we're going to associate and link the method get all cheeses handler, which we're going to be creating in the future, with that path in association with that request. And so for retrieving a single cheese, we do want to also pass in the cheese ID, which is why we're appending, after we have the path, the cheese as a parameter. And so as one of the reasons why we had our model conform to the parameter protocol, so that we can pass it in as part of our path. Now for posting, that's when we're going to be creating. And so using the create cheese handler, and the path is still the same, /cheeses. And then to update, we're all going to be doing the same as when we're getting a single cheese, which is going to be passing in the cheese as a parameter. And the same pattern for our delete, where we pass in our cheese as a parameter, since all of those three methods need to have some type of ID so that it knows what exactly to retrieve. So above in our boot method is where we define our paths, but in the actual struct is going to be where we implement the methods. And so just marking that off and then creating our first handler, which is going to be our creating cheese handler. And we're going to pass in the request within our parameter, and this method does have the chance of throwing an error, so we are going to denote our function with that by using the throws keyword. And we're returning a future cheese because the cheese will need time to be fetched from the database. And so we're just letting whatever method calls this handler, hey, you can expect a cheese in the future, perhaps, because there's a chance that it could throw an error. Now for our retrieve endpoint, similar pattern, except we're going to be returning an array of cheeses since we're going to be getting all of our cheeses. And then for our getting a single cheese, it's going to be a similar pattern as with our creating our cheese handler, where we're returning a single cheese, well, a future cheese. For our creating our cheese handler, we did return the cheese just so that the client knows, hey, this is the cheese that was actually created on the database. So it's a good reference. And then for our update endpoint, similar pattern where we're returning a future cheese. And now for our delete cheese handler, we've deleted the cheese, right? And so there's not really a cheese to return. And so for this one, we're actually going to return a future HTTP status. So just letting the client know, hey, it was successful, it wasn't successful, here's the status. And since we haven't actually implemented anything, we have tons of errors. Okay, so in our create cheese handler, we're going to go ahead and first try to decode the content that's passed in through the JSON body. And so we have to tell our code what we want that body to conform to. So whatever was just passed in, what is it, right? So we're going to decode it to a cheese model. And then we're going to go ahead and do a flat map. And so flat map is a really interesting concept because it allows us to chain multiple different actions together. And so we're going to do a flat map, which is, if we break it down, what we're doing is first we're getting the cheese that we've decoded, and then we're going to go ahead and boom, save that onto our request. And then once we finish that, we're going to go ahead and return the cheese. So that's what the flat map to cheeses part. That part is essentially letting it know, hey, this is what we're returning. And then once we save it, that's when it's actually going to execute that part of it. So for our get all cheeses handler, it's pretty straightforward since we're just going to be querying directly onto our model based off of our request and then returning all. For this one, we don't need to try it because we know that we're going to have that cheese table there. There's just a chance that our array is just empty. Now for getting a single cheese handler, this one we do need to try because there's a chance that it's not there. And we're going to go ahead and get the parameter and conform that parameter to our cheese. So the parameter is the ID that we passed in. And then once we take that request and say, hey, the parameter.next, that whatever parameter is next in line, that's what is taken. So once we do that, if we had another parameter, boom, it would take the next one right after. So for our updating cheese handler, we do see that we have multiple different flat map options. And so the 2 is going to be the result. You have AB, ABC, ABCD. So these are just really associated to the different events that you might have. Choose the one that's appropriate. So first we're going to go ahead, flat map, and the result is going to be a cheese model. And then the second thing we want to go ahead and take is going to be the parameter. And we're going to take the parameter. So this is our cheese ID. And we're going to conform that to a cheese model. And then our next parameter is going to be decoding the JSON body of the updated data. And it actually turns out that the flat map I chose has one too many options. No problems. I'm just going to delete that part and clean this up a little bit. And then we can go ahead and add the variables that we're going to be using in association to whatever we just flat mapped right there. So the first one is cheeses, which correlates to the parameter that we just got. And then the updated cheese correlates to the content that was decoded within our JSON body that was passed in. And so now down here, we can go ahead and update our model properties. So whatever variables you have, you can update. And one thing you want to do is update the updated app property with the current date. And then once we're done with that, you can go ahead and just save that updated cheese, which is going to be the original cheese model, onto your request. Okay, awesome. Slowly making progress. And you can see that the cheese, we have the result maps to that. And then the parameter maps to the first cheese, while the content decode matches to our updated cheese. And so really, like if we decoded our content first, and then we got our parameters, that was no big deal. We just need to make that switch when we're initializing our variables. Okay, for the last one is going to be deleting our cheese. And so first we're going to go ahead, try to get our cheese parameter, so the cheese ID. And then we're going to go ahead and do a direct delete onto our request. But then this is the part that changes it into an HTTP request. HTTP status, not request. We take that delete and then transform it to no content. And so it says, hey, if the delete is successful, we're going to go ahead, transform that result to no content. And then that is what's going to actually be returned. All right, coolios. We just did all our implementaciones. It's awesome. We did everything. Now, if we head back up to our boot method, you'll see that we did a little bit of repeating, and hashtag we're lazy coders. So, okay, lazy coders. We're lazy coders. So we can actually group the whole cheese's path. And so we're going to create a new route, and this is going to group our router underneath whatever path that we have. And so if you do have a common beginning path, this is how you would add that. And then we're going to go ahead and update all of our defined routes. And so for the first one, we're going to do cheeses.get, and then this is going to be a get directly on the slash API slash cheeses, and then using our method, and then cheeses dot routes dot get cheese parameter, that'll be slash API slash cheeses slash the cheese ID. So you're getting the idea of, if you have tons of different paths which essentially have the same beginning component, you can go ahead, group it, and make your life a lot easier. Hashtag efficient. Hashtag keep it dry. Don't repeat yourself. And just cleaning things up a little bit. CRUD. Create, retrieve, update, delete. Okay. Awesome. And one more update that I actually like to do with my APIs, instead of having the API root, I'm going to actually put in the API version. And so this is going to be a constant that I define within the constants file. So in the constants, I'm going to go ahead, add the property API version, and this is going to be a string. And by having it in the constants, it makes it a lot easier to make sure that all of your controllers have the same thing. Okay, so cool. So we have our API version, and we've cleaned that up. And oh, one more thing, a little bit. Yep. We're gonna go ahead and just add that next line. Yep. Okay. Yeah. All right. Cleaned up. You can head over to GitHub.
Hope this helps. Drop a comment and share if it did. This is the end of the recording. Bye.